These are the building instructions for the Bionic Hybrid X210. The frame parts can be downloaded from Thingiverse and printed on your own 3D printer or ordered through one of the associated companies. Fully assembled with motors, props and all the other bits and pieces, the model weighs in at only 365 grams. The model is built around the popular NACE32 flight controller. We're also using the Bionic PDB, which provides the 5 volts for the camera and the 12 volts for the VTX unit. We're using a camera which is the HS1177 camera made by Foxeer. Ensure you get the original here because the clones are not so good. The NACE32 and the PDB stack on top of each other using a 3D printed part. The flight controller mount is an extremely important part of the model. It allows the arms to be removed with just undoing 3 bolts. However, in testing I've never actually broke an arm yet. All the parts were designed using Fusion 360, and here you can see the camera assembly. Here you can see the rear of the model. The RX antennas are fed through tubes, actually 3D printed into the frame to keep them safe and out of the way of the blades and props. A little stubby VTX antenna is laid down inside the model. Because the model is made of plastic and not carbon fibre, it doesn't actually interfere with the signal strengths. As you can see, there's an XT60 at the back there in the model itself, so it's very difficult for the battery to become unplugged in a crash. And even squeezed into that tight space, we have a 3-in-1 lost model alarm. The lost model alarm can be heard from 100 meters and is exceptionally good value for £4. Here is a 3D view of the stack of components. The RX, the 3-in-1 lost model alarm and the XT60, all fitting to the back of the model. The model has been thoroughly tested for crash resistance and speed. Here we do a flight of 830 feet. That is 103 feet per second and calculates out at 70 miles an hour. Here we can see the inside of the top frame. We can see that there are 8 M3 45mm bolts that give strength to the frame itself. Remember that it weighs in at only 365 grams, so it's well worth putting these 8 bolts in to give it the strength and crash resistance. We can also see the tubes that the RX antennas lay through, keeping them out of the way of the props, and the little stubby VTX antenna inside the model itself. As stated before, the model is very crash resistant. The front of the model is almost 12mm thick, and as you can see there, in a heavy crash, the battery stays on and the model doesn't break. I've only ever actually broke this model twice. I've crumpled the front twice when I tried to get through a very, well, probably too small a tyre, and I hit the tyre wall side at almost full speed, and it crumpled the front, but actually the model was still flyable. Okay, so let's get on to what we're actually going to need in terms of hardware to build this model. Well, all these bolts here are M3, and I've put them in sections so you can see what they are. So there are a few repeats, so be careful of the sizes. So in the first section there we've got 4 10mm bolts. Then we've got 2 14mm bolts. We've then got another 8 10mm bolts. We've got the ones that cause the main structure of the frame, which are the 45mm, and there's 8 of those. And then we've got these little nylon hex standoffs with nylon bolts to hold the flight control into the top. So these are 6mm. Just be careful here because the length of the thread on these nylon hex sections need to be very tightly measured. So they are 5.8mm, and you may need to just chop those off with a pair of snips or something if they're a little bit long. Otherwise, the nuts, as we'll discuss later, the nuts inside the flight controller mount will touch and want to pull the flight control mount away from the actual model itself. We'll see this later on. You'll notice that most of the nuts are actually lock nuts with the nylon inserts, except for the 2 that go on the 14mm. They're just normal nuts. Now we've covered the hardware we need in terms of nuts and bolts, it's worthwhile looking at all the other parts of hardware we need, all the electronics. We can be ordering these while we're 3D printing the parts. So the first part we've pulled out here is the Bionic PDB. This is the part that gives us the 5 and the 12 volts that we're going to need, and sits just slightly below the flight controller, which we'll look at later. Unfortunately, these only seem to get 2.5 stars, but I've not really had much of an issue with them myself. I've got 3, and the only thing I can really point out is that they really don't like water, like dew on grass and things like that. So as part of this build, we shall actually be using Corrosion X, which is a very good waterproofing compound for electronics, and if you YouTube Corrosion X, you'll see what I mean. If you have a preferred PDB that you normally use, as long as it provides 12 volts and 5 volts, then it shouldn't really matter. So I'll leave that up to your own discretion. As long as it's the same footprint as this one, then you should get away with using this. However, if you are following this, maybe it's your first build, I would advise that you stick with the parts that I'm using as much as possible to ensure you can follow along as we build the model and start configuring it and getting it ready for flight, and then actually doing a test flight. That way you'll be able to share my settings and be able to just follow every step by step. You're also going to need to source some 14 AWG red and black cable and an XT60. You need the male connector as seen in the picture. You're also going to need to order some arms. Now we're using carbon fibre arms because all the models I've tried with 3D printed arms break really easily, and it just isn't worthwhile. So for the cost of carbon fibre arms, which I've yet to break during all the testing with this model, I think it's really good value for money. You'll need to order these from FPV Model, and they are for the ZMR X210, and you want the 4mm carbon fibre arms, the ones that are 210mm long. You'll also need 4 ESCs. Now, these are really a personal preference, and everybody's got their own opinion when it comes to ESCs. I'm only using these as part of this build because I have some spare, although I think if I was going to order some more, I'd probably order the little Bs. They are still available, these, so if you're following along, then please buy these, just so we can keep the step-by-step instructions. But if you're more experienced and you want to go it alone on this part, then I would probably order the little Bs, again available in a 20 amp model. So these I shall be using are the ZTW Spider Pro 20 amp. Again, motors is a very personal choice. Now, in my build I shall be using the Kylin 250 motors, which are reasonably expensive to be fair, so I wouldn't actually advise you buy those. If I was going to buy some, I can only really recommend the Multistar Elite 2204 2300 kilovolts motors, and simply because I know that these work with the ZTW ESCs that I shall be using. Again, it's a personal choice. You may have motors that you wish to use, so go for those if you want, but if you are following along, please use the motors as specified, so we know that your model will work at the end. Now, the one thing you're going to need plenty of is propellers. This is the part that will get broke. They will get damaged in a crash. Now often with these dowel props you can bend them back into shape. However, be careful because excessive vibrations from propellers actually cause distortion within the video signal. So it's always worth changing them once they get really quite damaged, and eventually they will break, so I'd order quite a few. Now I buy mine from Surveil Zone. They're really quite cheap, so check out the links. The links, by the way, for all the parts mentioned here are actually on the Thingiverse site. So if you look on the Thingiverse site, you will find all the links for all the parts that I'm showing you here. So next we're looking at the main flight controller. Now this is the key to the model. It's the NACE32. Now you need to be careful in getting the NACE32 because there are many revisions available. Revision 5 is still quite available, but it's not as well designed in terms of layout. So we want the NACE32 Revision 6 Acro model. It's available through Hobby King and lots of different places like eBay. Just look round and get a reasonably good source. The receiver unit for your transmitter, this is going to be a bit of a problem if you're following along, because unless you've got a Taranis, you're not going to be able to use the X4R. So this is going to cause us a few problems for those people following along. You may have a Spectrum receiver or a Futaba, but all I can say is you need to get a receiver that will fit in this very small space. So look for one that's really quite small. Just to be clear that you make sure you get the right model, you're going to need 6 channels in total to drive this model. This is the most important part as far as I'm concerned. You are going to lose this model. It will fly at some distance and some speed, and without a lost model finder that is working before you try and fly it, you're probably going to end up losing the model quite quickly. So you need to get one of these. It's a turnkey 3-in-1 battery monitor, signal loss and lost aeroplane alarm. Like I said previously, for less than £4 it's an exceptionally good buy, and that, trust me, you will hear this from 100 metres. Assuming you've got reasonably good hearing, of course. What follows next is a few optional extras. Now, if you're going to fly in line of sight, then you wouldn't actually need this. This is the part that sends the signal back to the goggles, assuming you want to fly FPV. Now, you may just decide to fly a line of sight model or build a line of sight model first, which is entirely up to you, but don't think that there's any learning curve here. Learning line of sight is completely different to learning FPV, in my opinion. So here we have an eMachines TS5828S. It's a 40-channel 5.8 GHz VTX unit. I prefer to buy the RP SMA connector, and if you're following along, like I've said before, try and get the exact same part. Just a point to note, the legal limit in the UK is actually only 25 milliwatt, so you may want to stick legal, or you may want to decide to just go and push the boundaries. These are exceptionally good value for money, and they're from Banggood. They are a little stumpy VTX antenna which sits inside the model, and well recommended. Remember that because the model's plastic, it means that there will be no interference like you get with carbon fibre with aerials, so it can sit inside the model quite comfortably and still not actually affect the signal back at the goggles. Again, this is optional. You only need it if you're going to be actually flying FPV and not line of sight. Another optional extra if you're flying FPV is this HS1177 camera. Now, it's very important that you don't actually buy a fake one here. There are a lot of fakes on the market. I buy mine from hobbyrc.co.uk because I'm absolutely assured that they only buy from the manufacturer, and I've spoke to the guy on the phone and I believe him. I've now ordered 3 and every one of them has been an original. And here it is, the most important part if you're flying FPV. Again, it's optional if you're flying line of sight. Now these are very expensive goggles, I appreciate that, but they are really, really good. What I would say about goggles is ensure that you try them out first, because all goggles don't actually fit. Everybody's face is different, and that's all I can say, and you really need to try them before you buy. So if you've got a friend or somebody who does this as a hobby, see if you can borrow theirs and use theirs for a little while, and see if you get on with them before you make this, which is really quite a significant purchase at over £200. Okay, so that's it, covering all the parts. So for part 1 we'll wrap up. In part 2 we'll actually start printing the components, and we'll look at the settings we're using on the 3D printer, and we'll be cleaning up the components and getting ready to start building the model. Hopefully we'll be doing that in the next few days. Thanks for watching.